This is a Unit 3 test review. It starts with solving equations. So number 1 is 6 minus 9y equal to negative 12y. So I'm going to start by isolating my variable. So I need to move one of the variables so that they're both on the same side. So I'm going to move the 9 since 12 is already by itself. I'm going to do that by doing the opposite. So plus 9y gives me 6 on this side, and negative 12 plus 9 is 3y. And then to solve this, I need to divide by 3, and so y is equal to 2. All right, with any equation, you can always go back and check your answer. I'm going to do it on this first one, and then if you want to continue to do that, you can. But I just want you to see how it works. So 6 minus 9, and then I'm going to replace, this should have been a negative 3y here, so I'm actually dividing by negative 3. So this is actually negative 2. All right, so then when I replace y with my solution, I'm going to have 6 minus 9 times negative 2. And then on the other side, I'm going to have negative 12 times negative 2. All right, so then if I go ahead and simplify both sides, negative 9 times negative 2, I'm doing order of operations here, so I have to multiply first. So 6 plus 18. And on this side, I get a positive 24. 6 plus 18 is 24. And since both of these are equal to each other, then negative 2 is the solution. Now, if I had not caught this earlier mistake and used a positive 2, I would have ended up with 2 different answers, and so I would know that there's something wrong with my solution. All right, so let's keep going. On number 2, I'm going to cut it in half, isolate the n by doing the opposite of subtracting 15. You always start with the number being added or subtracted and get rid of that one first. I always leave my variable to the end unless I'm moving it to one side. All right, so this is 6 equal to 2/5 n. And then to do the opposite of multiplying by 2/5 n, I need to divide by 2/5. Okay, and so I could write that out, divided by 2/5, divided by 2/5. But since I know that dividing by 2/5 is really just going to make me multiply by the reciprocal, I'm going to kind of skip that step and just do the multiplying by the reciprocal. If you want to, I mean, you can still do 6 divided by 2/5, show that step, and then flip it, but it's the same thing. I need to make this 6 over 1, and then I'm going to do 5 times 6 is 30, 2 times 1 is 2, and then on this side, these go away, this is just n, and then if I simplify 30 over 2, I end up with 15. Okay. On number 3, I want to start by distributing, so 3 times v and 3 times 5 is 3v minus 15. On this side, I'm going to distribute the negative 2, so negative 24. And then negative 2 times 3 is negative 6. So I could put plus negative 6v, or I could just write minus 6v. Again, in this chapter, is really, you'll do yourself a favor if you start to think of negatives and subtraction kind of as being the same idea. All right, so if I go ahead now and try to isolate my variable, I'm going to move the 6v because that'll make it positive. So that gives me 9v minus 15 equal to negative 24. And then over here, I want to get rid of the 15, so I'm going to add, because that's the opposite, and that would give me 9v. Negative 24 plus 15 is going to be negative 9, and then to solve for v, I need to divide by 9, so v is equal to negative 1. All right, on number 4, I have negative 7b minus 5 minus 2b equal to negative 4b plus 10. So first I want to simplify. I have some like terms here that I can combine. I have a negative 7 minus 2. So that's like a negative 7 plus a negative 2 is negative 9b. And then if I go ahead now and start isolating my variable, I'm going to move the 9 because that'll make it positive. So plus 9b. So this becomes negative 5 equal to 5b plus 10. Now I'm going to move the 10 by doing the opposite, which is subtracting 10. That's 5b. So again, this is one of those cases where you can think of this as 5 minus 10. But that's the same thing as negative 5 minus 10. But that's the same thing as negative 5 plus negative 10, which is still negative 15. And then to solve for b, I need to divide by 5. So b is equal to negative 3. Okay. On number 5, it says 2/3 x minus 4 equals 11/6x plus 10. So I want to, I don't have anything to simplify on both sides of this equation, but I do have fractions that need common denominators. So I'm going to go ahead and find the common denominator of 3 and 6. So that would be 6. So I'm going to multiply by 2. That gives me 4 6x minus 4 equal to 11 6x plus 10. And then I'm going to move one of my variables. So I'm going to move the smaller one. So minus 4 6x. Oops. Gives me negative 4 on this side. 11 minus 4 is 7 6x plus 10. Then I'm going to move the 10, subtracting that. So this is 7 6x. Negative 4 plus negative 10 is negative 14. All right, and then here again, I have one of those fractions where I need to divide by 7 6, but I know that dividing by a fraction is the same thing as multiplying by its reciprocal, so I'm just going to skip to that step. 6 over 7. This becomes negative 14 over 1, and then I'm going to multiply. So 14 times 6 is 24. That would be 84. So negative 84 over 7 times 1 is 7, and then that can be simplified. If I divide 7 into 84, if you don't know that already, it's going to be 12. So then x ends up being, sorry, this ran out of room. So negative 84 over 7 simplifies to negative 12. All right, and then 6, we haven't really seen a problem like this before, but I want you to see it because it could come up later on a STAR test or something like that. So in this problem, normally we do the adding and subtracting part first, but because this whole quantity is being divided by 4, we're going to get rid of that first. And so the opposite of dividing by 4 would be multiplying by 4. All right, so I'm going to multiply. It's like I'm multiplying this whole thing by 4, multiplying this side by 4. All right, so these 4 go away because it's like 4 over 1, and so I still have the x plus 5 on this side, and then 4 times negative 4 is going to be negative 16, and then to solve it, I'm going to subtract 5. Okay, again, negative 16 minus 5, same thing as negative 16 plus negative 5, so negative 21. That's my answer. On number 7, it says the table shows the number of students in each 6th grade classroom, in each 6th grade homeroom at Wagner Middle School. If the total number of students in homerooms A and B are equal to the total number of students in homeroom C and D, how many students are in homeroom A? Okay, so I'm going to take A and B and find the total, so that would be adding, so A plus 4 times A minus 3. And then that is supposed to equal the total students in C and D, so that would be 15 plus 2A plus 9. Okay, so I'm just going to simplify this first by distributing the 4, so that gives me 4A minus 12. Over here I can go ahead and combine the 15 and the 9. These are both constants, so I can add those together. It gives me 24 plus 2A. All right, I can still combine my a's here, so 5a minus 12 equals 24 plus 2a. And then I'm back to just a regular equation. So I'm going to move the 2a because it's smaller. That gives me 3a minus 12 equal to 24. Then I'm going to move the 12 by adding. That gives me 3a equal to 36. I'm going to divide by 3, so a is equal to 12. All right, and it says how many students are in homeroom A. So since A is A, then A is 12. That's my final answer. Okay. On number 8, it says which corresponding real-world problem does not represent 600 minus 30W equal to 250. All right, so it says Stefan wants to have $250 in his savings account by the end of the semester. He begins with $600 in his account. If he withdraws $30 weekly, how many weeks can Stefan withdraw money and still meet his budget? Okay, so he wants to end up with $250, so that would equal $250. He's starting with $600, and he's withdrawing, so he's spending $30 per week, and we're trying to figure out how many weeks. So $30 per week would be like 30W, so, and since we're withdrawing it, it would be minus. So this one is a correct way to represent it. So since we're looking for not, this is not our answer. Derek has no more than $250 in his checking account. He deposits $30 a week and receives a bonus check of $600. How many weeks will it take to have more than 600. All right, so in this one, I'm depositing, so I'm adding the $30 a week. I also got a check, a bonus check of 600, so that's going to increase my account. And I already have no more than 250 in his checking account. So if I want to know how many weeks it will take to have more than $600, there's lots of problems with this one. He has no more than 250. He's going to deposit that. So I guess we're adding that to 250. Okay, and then how many will it have? How many weeks will it take to have more than $600? So more than $600. This does not make any sense because he already has more than $600. All right, so it's definitely not this one. Letter C. Kevin currently has $600 in his account. He's withdrawing $30 a week. How many weeks can Kevin withdraw money before his account balance is $250? So he has 600 in his account. Let's see. He has 600 in his account. And then he wants to withdraw 30 a week, so he's subtracting 30 a week. And then he wants to know how much, so that's equal to 250. All right, so again, those two match. So it's definitely not these two. Oh, it could be this one, right? Because I'm looking for not, I forgot that for a second. All right, Eric opens a checking account with an initial deposit of $600. He needs $250 in his account at the end of the year. He transfers $30 from his account each week. How many weeks will it be before Eric reaches an account balance of $250? Okay, so he's starting with 600. If he's transferring out of his account each week, then he's going to be decreasing it by 30 each week. He wants 250 remaining, so that would equal 250. Okay, so since A, C, and D both work, then B is the answer, right? It does not represent, this problem does not represent this equation, right? And then number 9, it says consider the model below, write an equation that represents the model. So, so I have a balance scale here, so that's like the two parts of my equation. On one side, I have 4 negatives, so that would be -4. On this side, I have 6 positives, and I have 2 x's, so I would write that as 6 plus 2x. And then it just says write the equation, so I'm going to leave it. -4 equals 6 plus 2x. You could also put the 2x first and make it 2x plus 6, same answer. Number 10, 9 plus x over 5 greater than 3. So I'm going to solve inequalities the same as I solve equations. I'm going to move the 9 first. So in order to get rid of a positive 9, the 9's being added, I need to add a -9, or I need to subtract 9. So this becomes x over 5 greater than 3 and -9. Give me -6. I need to solve for x, so I'm going to do the opposite, which would be to multiply by 5, since this is division. So x is greater than -30. Now, because I multiplied by a positive number, this is not the exception to the rule where I switch the inequality. So this stays greater than. I'm just going to pick a point on the line. Since it's only greater than and not greater than or equal to, I have an open circle, and then the numbers greater than -30 are going to be to the right. Okay. On 11, I'm going to again start like an equation. I'm going to move the 7 by adding 7. So this becomes -6x greater than or equal to 24. And then I'm going to divide by -6 to solve this. So x on this side, 24 divided by -6 is -4 on this side. And then because the number I divide it by is negative, this is that exception where I have to switch my inequality, and now this is x less than or equal to -4. All right, so when I graph this one, I'm going to pick a point. This time it's a closed circle because of the equal to, and then the number is less than -4 this way. On 12, I'm going to move the 3x. So that gives me 25 less than or equal to 8x plus 1. And then I'm going to move the 1, so subtracting 1. So this gives me 24 less than or equal to 8x. I'm going to divide by 8. So now I have 3 less than or equal to x, which is the correct answer, but it's a little harder to graph. So I'm going to go ahead and switch it. This is the only time where it's really maybe not even better, just easier to have the variable on the left side. But when I flip it, I have to switch everything. So this becomes x greater than -3. So then when I graph it, it's going to be a closed circle at 3 to the right. On 13, I'm going to start by moving one of the two w's. So if I add 2w here, and I add 2w here, what happens is that these cancel, but these cancel as well. So all I'm left with is 4 greater than -9. All right, so when that happens, if you get a true statement, is 4 greater than -9, then your answer is all real numbers. So any number you put in for x is going to work. All right, and on a number line, that would be the whole number line. Anything you find on a number line would work. All right, on 14, I need to distribute the -3/4, so I can think of these as fractions and do top times the top, bottom times the bottom. So this becomes -24m over 4, and this becomes a negative times a negative is a positive. 3 times 16 is 48 over 4, greater than -12. If I simplify those, I'm going to get -6m plus 12 greater than -12. So if I move my 12, that gives me -6m greater than -24. I divide by -6, I'm going to get an m and 4. Again, I divide it by a negative, so that switches my inequality. And also, the rule works if you multiply by a negative. All right, so then at 4, I'm going to have an open circle this time because there's no equal, and it's going to go to the left. Okay. All right, on 15, it says the A1 Arts Learning Center charges a one-time fee of $26 plus $10 per piano lesson. The charges to learn to play guitar are a one-time fee of $36 plus $8 for each lesson. After how many lessons will the cost of learning to play piano be the same or more than learning to play the guitar? All right, so for the piano, I have $26 that I have to pay, and then per lesson would be like 10 times, we'll say P. And then on the guitar, there's a one-time fee of $36 plus $8 per lesson. And I want to know when the cost of playing the piano will be the same or more than, so greater than or equal to, playing the guitar. Okay, so this is my piano over here. This is my guitar over here. All right, so this is just a regular inequality. I'm going to move my 8p. So this becomes 26 plus 2p greater than or equal to 36. Then I'm going to move the 26. So 2p is greater than or equal to 10. And then if I divide by 2, p is going to be greater than or equal to 5. All right? So what are we saying? After how many lessons will the cost of learning to play the piano be the same or more than learning to play the guitar? After 5 lessons, it's the same. After more than 5 lessons, it's going to be more. On 16, it says, look at the inequality shown. Which situation best matches the inequality? So this time I'm looking for the one that is correct. Melina earns $9.25 per hour babysitting. She needs $85 to attend a concert. If she spends at most $120 on clothes at the mall, how many hours must Melina work to be able to afford the concert? So at most means she would, that would be the maximum, right, that she would spend. So at most would be less than or equal to. Okay, since I'm looking for greater than or equal to, then I know it's not going to be a. Melina babysits 9.25 hours per week. She needs a minimum of $85 to attend a concert. If she spends $120 on clothes at the mall, how much money must Melina earn to be able to afford the concert? So she's babysitting per week. She needs a minimum of $85. So minimum would be greater than or equal to. So this is possible. So if she's babysitting per week, that would be 9.25 times however long she works. She needs a minimum that would be greater than or equal to 85 to attend the concert. If she spends $120 at the mall, how much? So minus 120. Okay, so that's a possibility. Melina earns $9.25 per hour babysitting. She needs a minimum of $85 for the concert. Let's see, she needs, if she spends $120 on clothes at the mall, how many hours must Melina work to be able to afford the concert? All right, so she's working $9.25 per hour. She's spending $120 on clothes at the mall, and she needs a minimum. So again, minimum, it's going to be greater than or equal to 85. All right, so I need to look at those more closely because it looks like they're both the same. Melina works $9.25 hours per week babysitting. She needs $85 to attend a concert. If she spends a maximum, it would be what, less than or equal to $120. How much money must she earn to afford the concert? Okay, so I know it's not this one because I'm not going to use less than or equal to. So I need to go back and see if I missed something the first time I read it. Okay, so in this one, it tells us hours per week. So when I solve this equation, x, I'm actually going to be solving for how many weeks she has to work in order to be able to go to the concert. But the question is, how much money does she have to earn to be able to go to the concert? Okay, in this one, I'm doing $9.25 per hour babysitting. And the question is, how many hours must she work to be able to afford the concert? So in this one, x is hours, and that's what I would solve for. This one, x is hours, but it doesn't answer the question. I could use it to answer the question, but I would say this one best represents this inequality because this is an inequality that works best for this situation. Okay. All right, on 17. It says Cindy solves the inequality as shown below. Identify any mistakes Cindy may have made. Let's see. Okay, so I want to start by moving the 3. They started by moving the 3. That's fine. They did the opposite. All right, so when I add that, I have to add a 0. That gives me 7.5, which is correct. And then this is the negative. They moved to the bottom. That's fine. And then they multiplied by -3 on both sides. That's correct. Okay, so those go away. This is x. On this side, 7.5 times 3 is 22.5, so that's right. It's negative. Okay, so the only thing they messed up on is they multiplied by a negative and they did not switch the inequality. So A, she subtracted, that's right. She divided. No, we don't want to divide. We want to multiply by -3. Oh, we wanted to add by 3. She did not make any mistakes. She did not change. Okay, so she did not change the direction of the inequality symbol after multiplying both sides of the inequality by a negative number. 18, which represents a possible solution set for the inequality shown below. You're going to go ahead and I guess I'll just solve it. So if I add 6, I get -3/4 A greater than 9. And then I'm going to multiply by the reciprocal because this is dividing. To solve this, I need to divide. It's the same thing. Multiply by the reciprocal. Okay, those go away. This is A. This gives me -36/3. I multiplied by a negative, so remember to switch the inequality. So this becomes A less than -12. So if I look at which of the sets contain numbers less than -12, it would not be A or B. C is less than -12. D is not, so it has to be C. Okay, you could also substitute numbers in, but that's going to take you a long time. All right, and I'm going to stop this video and do the second part of the review, or the last part of the review on a second video because they get kind of long. All right, I'll see you in a minute.